Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about runtime polymorphism in Java. We will understand what it is, how it works, the requirements to achieve it, and also we will see some practical examples. So by the end of this video, you will have a clear understanding of one of the core concepts of object-oriented programming, that is runtime polymorphism. So let's get started. So as we already know, poly means many, morphism means form. So polymorphism means many forms. Okay. And we have seen like one method with many forms. Forms means implementations. Implementation means definition. Means same method name, but different definitions, different implementations. Okay, so method name will be same, but inside definition will be different. Okay, so that's what polymorphism. Now, what is runtime polymorphism? Okay, so runtime polymorphism is one of the feature in Java where the method that gets executed is decided while the program is running. Okay, so which method it will execute, that particular method is decided during the runtime. That's why it is called runtime polymorphism. So instead of selecting the method, which method to execute, okay, during compilation, Java waits until runtime and executes the overridden method based on the actual object. Okay, how it is achieved? Using method overriding. Okay, so I will give you some examples so that you will have better understanding. So for runtime polymorphism, so first of all we'll revisit the definitions. Okay, so what do we mean by method binding? First of all, what do you mean by method? Oh, sorry, binding. Method binding means what? Linking method call to method definition. So I hope by this time you know what is method definition. Okay, method definition means whatever method, inside method whatever we are writing, so that is definition. Okay, so and method call means we are calling the method. We have defined some method, and in one line we are calling that method. Okay, so linking method call with method definition is called method binding. So this is like very basic. Okay, now we understood what is method binding. Okay, and if method binding is happening during compile time, we call it as compile time polymorphism. And when method binding is happening during runtime, then we will call it as runtime polymorphism. As simple as that. Okay, so method binding means what? Which method to execute. So based on method call, it will decide during runtime which method to call, which method will be called, which method definition. So that is method binding, and it is happening during runtime. Okay, now we will be having parent class. Okay, as parent. Now we will be having one child class that will be extends from parent. inheritance. Okay, we have seen in the concept of inheritance. So what we have seen in inheritance, so whatever properties and behavior that parent is having, that will automatically come into child class, automatically can be accessed by the child class. Okay, so let's say we have method xyz inside parent class. So child class can directly call this xyz method, directly access this method. Okay, but this child class don't want to execute this method, this implementation, this definition, this method definition. Child class wants to change the definition of whatever definition xyz method has. Okay, so what it will do, it wants to keep the method name same, that is xyz, but child class wants to change the definition. Then what it will do, it cannot directly execute, right? Since xyz method is inherited to the class child, if it executes means, so whatever definition it is currently having, that will be executed. But the requirement is child class wants to update that definition. So what it will do, child class will override xyz method, and it will provide its own implementation, its own definition. Okay, so that is the process. So now you can see, you go to the definition of polymorphism. What is the definition of polymorphism? One method with multiple forms, method, multiple implementation, multiple definition. See, one method name xyz, method name is same, right? Now, but different definition, different implementation. So that is polymorphism. One method name but multiple forms, many forms. That is polymorphism. But why we are calling runtime polymorphism? But here in this case, we are using the concept of parent and child. Since child can access this xyz method, but child class wants to change the definition of this method. So child class override the same method and change the definition based on child class requirement. So method name is same, but definition is different. Here definition is different. Okay, so now we have two methods xyz. Which method will be getting called? What we have learned so far, runtime means, what we have learned so far, method binding. Method binding means what? Linking method call to method definition. Okay, I am calling, suppose let's say I am calling method xyz. This is method call, and these are method definition. This is method definition, this is method definition. This is method definition of parent, this one is the method definition of child, and this is method call. What is method binding? Method binding is linking method call to the method definition. Okay, and linking method call to method definition. How it will link? How it will link the method definition? Okay, so before that, I will tell you the rules of override. See, here it has overriding this method, right? I hope you remember the set of rules for overloading. So likewise, in this case, we have set of rules for override. Okay, what are those rules for override? So override means method name should be same. This is first rule. Okay, method name should be same. This is first rule, and the number of parameters and the data type should be same. This is second rule. Okay, so I will write here, method name should be same and number of parameters should be same and data type of the parameter should be same. This should be what? Same. Only what is the difference? Implementation or definition of the method, that will be different. Okay, so this is the rule of override. So by following this rule, child class will override this method. Okay, so if you remember, for overloading based on the number of parameter or the data type or both, the method call was linking to the method definition. But in this case, everything is same. Method name is same, signature is same. Only definition is different. So let's say we have one class, okay, one class called person. Okay, person. In this class, let's say we have one method. Okay, let's say int add and int a comma int b and return a plus b. Okay, so this is the method defined inside person class. Now we have one more class called let's say employee, and inside this employee class we are overriding this method add, and what we have learned, the signature will be same. Signature means number of parameter and data type of the parameter will be same. Only definition will be different. So this time I am returning a plus b plus 2, let's say. Only I am changing definition. Okay, so far we have understood class person. Okay, here I need to write expands person, since employee is the child class of person parent class. Okay, so employee is a child class and person is the parent class. So this method will automatically be inherited to the employee class. So employee class can directly use this method. Okay, employee class can directly use this method, but employee class wants to change the definition of this method, which is this line definition. So what it is doing, it is overriding this method in the employee class, in the child class, and changing the definition of this method by adding plus 2. That's why we have done override. Okay, now what is the rule of override? So rules of override we have seen, like method name should be same, number of parameters should be same, data type should be same. See, int, data type is same. Okay, and the this is return type. Return type can be same or one lower. So let's say instead of int, here we have double. So it can be double or int. So return type can be same or one size lower. That is the rule for return type. And what is the rule for access modifier? Let's say it is protected. What is the rule for access modifier? So access modifier can be same or it can be wider. So it can be either protected or it can be public. So this is the rule for access modifier, and this is the rule for return type. So for return type, it can be same or one size lower of parent class return type. So it can here we can write double or int as a return type in the child class. And the rule for access modifier while overriding is it can be same of the parent class access modifier, that is parent class method access modifier, or it can be wider. So public is the widest, right? So protected or public can be used as access modifier. So these are the rules of method overriding. Okay, so until overriding it is clear. Now we know the method binding. Now we will call the method. Let's say, okay, before calling, just tell me that what is method binding? Linking method call to the method definition. Okay, so previously we were writing like this. Okay, add let's say 1.2 comma 2.2. So which method it will call? Like that we were saying, two parameters and both are of integer type. So this will call this method, but this time signature is same for both methods. See, parameter is same, number of parameter is same, data type is same. For method overloading it was different. So based on the arguments, based on the data type, this method call was linking to the method definition. But since here signatures are same, everything is same here for the method, both methods, only definitions are different. So in this case method binding will happen on the basis of what type of object it is referring. Type of object it is referring. What does it mean? Don't worry, I will explain. Okay, so for runtime polymorphism, the concept of inheritance comes. Since it is inheritance, right? Person is parent class, employee is child class, and we have override the method. Now overriding the method. Now let's say we are creating a child class object, employee equals to new employee, child class object. Now this is what object reference, it is referring to object. This is reference variable, object reference. Now we will call the method e.add, let's say 2, 3. So this is what method call. We are calling the method. Okay, and what is method binding? Linking method call to method definitions. These are method definitions. But the question is, this method call will execute which definition? So the answer is the type of object it is referring to. So we are calling this this is method call. We are calling this method with object reference e. Which object it is referring to? What it is written? Type of object it is referring. So which type of object it is referring? E equals to new employee. So which object it is referring to? Employee. So this method call will link to the employee class method. This method will get called. Why? Because it is referring to employee object. So for runtime polymorphism, this is happening in runtime. That's why we are saying runtime polymorphism, nothing more than that. So for runtime polymorphism, method binding, that is linking method call to method definition. Okay, which method definition to link is decided based on the type of object it is referring. So which type of object this is referring? It is referring to employee class object. So this method will call link to the method definition of employee class, that is child class. So that's how method binding during runtime takes place. Now you must be thinking, then when this method will get called? So the type of object, see, we created employee class object and we are calling add method. That's why employee class method is getting called. Now if we create person class, person p equal to new person. New person means what? Person class object, right? New person means person class object. And if we call p dot add whatever the parameter, so since this is referring to person class object, p is referring to where? Person class object, and from p we are calling add method. So it will call, this will call person class method. So here in the concept of inheritance, parent class object, so the type of object, whether it is parent class object, whether it is child class object, it is referring to which object. So whenever we'll call the method, we will call like this, right? P dot means the reference variable dot method name. So the reference variable is referring to which object? New person. So it will call person class method. If it is referring to new employee, that is child class, then child class method will be get called. So the type of object it is referring, so that type of object, that type of object's class will get linked to this method call. And this linking of method call to method definition is happening, that is method binding is happening during runtime. That's why we are calling it as runtime polymorphism. Okay. So now let's understand. Okay. Before taking one example, I will revisit this one. So here what method overriding, we have seen what are the rules of method overriding, right? Same method name, same number of, same signature. Method name should be same, signature should be same. Signature means what? Type, number of parameters, type of data type. Okay, so these are the rules of method overriding. And for one more rule also we have seen, for return type it can be, for child class it can be same or one lower size. And for access modifier, if parent class is having whatever, so the is having protected, then it can be one wider, protected or public. That is for access modifier. So these are the rules for method overriding. And whatever method binding, linking method call to method definition is happening during execution. That's why we call it as dynamic method dispatch. Dispatch we know, right? Dispatch means delivery kind of thing. And dynamic means during runtime it is telling, method binding is happening means it is telling which method to call. During runtime it is telling which method to call, and that method is being dispatched. That's why we are calling dynamic method dispatch. Okay, if your concept is clear, means you can learn very easily. Okay, so this is one example. Payment system. Okay, so we have one system, and these are the like credit card payment and UPI payment. These are the two different ways of doing payment. Okay, and we can add one more. Let's say net banking. Okay, so these are what different payments. So let's think like there is one online shopping application. Okay, now every payment method performs a payment. Okay, so we have different payment methods: credit card, UPI, net banking, and each of the method performs a payment. Okay, so I'm giving you one real life example, so think that way. So we are having online shopping application. We have different payment methods: credit card, UPI, net banking. Okay, so every payment method performs a payment. Simple. But each one process it differently. See, with this three option, no doubt payment will be done, but the process will be different for this one. Process will be different for this one. Process will be different for this one. What do you mean by process? Definition of this method, definition of this method, definition of this method, process, definition, implementation, whatever you say. So whatever method we will create, the inside the method we will be having definition, implementation. So those things will be different for all of these three. But the final output will be payment will be done. Payment. So a credit card payment follows one process. UPI payment, another process, and net banking, another. So each of the payment has their own implementation. Okay, but so implementation is different, but method name will be same. Okay, method name will be same. What we are learning? Polymorphism. What is polymorphism? Same method name with different implementation, different functionality. Okay, so method name will be same for all these three, but definition will be different, implementation will be different, process will be different. Same method name with multiple forms, polymorphism, one functionality, multiple forms, implementation. Okay, so let's say method name is pay. I am taking example pay. Okay. Now inside this method, definitions are different for all of the three. So the actual implementation depends on the payment method selected at runtime. So we have three ways, and all these three contains same method name, pay, pay, pay. Okay, but the definitions are different. And the question is, you all know, right? Method binding. Method binding means what? Linking method call to method definition. That means if you are calling somewhere method pay, passing some parameter, this is method call. Method call. Now the question comes, out of these three method, which method will get called? This is method call, these are method definitions. And method binding is linking method call to method definition. But out of these three, which method definition will link to this method call? That is the question. So just now in the previous example we have seen, right? So the type of object it is referring to, we will be calling this method, right? Like something C dot or whatever, UPI dot or maybe net banking dot. So whatever, this will be reference variable. So this reference variable is referring to which class object. So that class object will be, that class object method will get called. So this method will be present in three different classes. So that object's class method will get called. So method binding is happening during runtime. That's why we are calling runtime polymorphism. Okay. Don't worry, I will explain in IntelliJ also. So what are the requirements of runtime polymorphism? What we have seen, inheritance. There will be parent class, then child class. So whatever method is there, same method child class can use, but child class wants different implementation, different functionality with the same method name. So method name will be same in parent and child, but definition will be different. So child is overriding parent class method. Okay. And during runtime, what object is calling, what class object is calling, child class object is calling the method name, then child class definition will get called. If parent class object is calling the method, then parent class method will get called. So during runtime, what type of object it is referring, so that particular class method will get called. That means method binding will happen during runtime. That's why we are calling runtime polymorphism. And we are doing overriding. Yes, we did overriding in class, child class, parent class, reference. Okay, so what type of reference what type of object it is referring to. So that object's class will get, method will get called. Okay, child class object. If child class object, that means child class method will get called. If parent class object means parent class object, parent class method will get called. So 4 things are required to achieve runtime polymorphism. First thing, there must be inheritance between classes. Second, the child class should override the parent class method. Third, we use a parent class reference. And finally, that reference should point to a child class object. So whatever class object, so new, whatever class is there, whatever class object is created, it is referring to, so that class method will get called. That class method will get called. So the type of object is important. Okay. So together, this allow Java to decide the method, which method to call during a runtime. Now let's go to IntelliJ and implement these things, so we'll have better clarity. So let's say I will create one class called payment. Okay, payment. This is the class, and in this payment class I have one method, let's say pay. Same method I'm taking, pay, which I explained you in the slide. Okay, pay method. Now in this payment method pay, I will write processing payment. Okay, so this is one class. Okay, now I will create one more class, new, let's say credit card. Okay, yeah, credit card payment. And in this class also, okay, so credit card payment, and this is payment class. So payment class is what? Parent class. Credit card payment is what? Child class. So you know, right? Inheritance, the concept of inheritance we have seen. So child class will extend from parent class. What is the name of parent class? Payment. So child class will now have the properties and behavior from the parent class. So let's go and check what properties and behavior parent class is having. So payment class, parent class is having only one behavior, one method, that is pay. So child class credit card payment can access this pay method inside credit card payment class. But credit card payment wants to change the implementation. Implementation means this line. Now credit card payment will override this method in child class and provide its own implementation. How it will override? So we have one annotation, override. Okay, this is not compulsory, this is recommended. Okay, so why recommended? Because during compile time only it will tell you that you are not following override rules if you violate any rules. Okay, so what is the method name? Pay. Okay, so I will define same method name, same signature. Signature means number of parameters. So since there is no parameter in the parent class, I will also not define. And inside this, I will change the implementation. I will write here payment. Payment done using credit card. So I changed the implementation of this method. So same method name in parent class and child, but child is overriding that method in the child class, in its own class. Why? Because it wants to change the implementation. Now the main, some other class in the main method, we are creating object of what? Child class new. New means what? We know, right? New, whenever we use new keyword, the object will get created in the heap memory. Okay, but which class object? So if we are using new credit card, that means credit card payment object will get created in the heap memory. Now payment, we'll call the method of payment.pay. Okay, so now tell me in this line which class method will execute. I will show you again. See, payment class is parent class. Parent class is having pay method. This is child class. Credit card payment extends payment. So this is child class. This child class also have pay method. So both class are having pay method and implementation are different for both class. Now the question comes and we are calling the pay method. So since the pay method is available in parent and child class, which method will get called? So the answer to this question is the type of object it is referring to. So payment, we are calling method how? Using payment, right? Payment is what? Reference variable. So reference variable is referring to which object? Reference variable is referring to which object? Credit card payment. See, new credit card payment. So this method is getting called by object reference, and this object reference is referring to which class object? Credit card payment. So credit card payment class method will get called. So what is the credit card payment method? Is printing payment done using credit card. Okay, so now let's run. So the output should come credit card payment done using credit card. Okay, see in the output payment done using credit card. Now the reference variable which is calling the pay method, this reference variable is referring to credit card payment class. That's why the pay method of this class is executed, and this all things is happening during runtime. Okay, see, one method name with multiple forms, multiple implementations. See, same method name in payment, same method name in child class. And during runtime it is getting decided which class method will get called. That is runtime polymorphism. So the method this reference variable is calling, so the reference variable which object it is referring to. Now I will change this class to payment. Now tell me, this method is being called using reference variable, and this reference variable is referring to which class object? Payment class object. So now payment class method pay will get called. What is in the payment class method pay? Processing payment. Now the output should come. Processing payment. Let's verify. See. So this is runtime polymorphism. During runtime, Java is deciding which method to call. On what basis it is deciding which method to call? On the basis of reference variable. Reference variable is referring to which class object? So reference variable is referring to payment class object. That's why payment class pay method is getting called. And if we change this thing to credit card, so now the reference variable is referring to credit card payment. So credit card payment class pay method will get called. Let's verify. So one method with multiple forms, polymorphism, and these things, which method to call is being decided during runtime. That is method binding, linking method call. This is what method call. This is what method call, and these are method definition. Method definition. This is method definition, and in the same line only, okay, I will write here only. So here only method binding is taking place. What is method binding? Linking method call to method definition. On what basis? On what basis method binding is happening? So method binding is happening on the basis of the reference variable is referring to which class object. So where is the reference variable? Payment. Payment is calling this method, right? So this is a reference variable. Reference variable is referring to which class object? Credit card. So that class object's method will get called. So this class method which is pay will get called. So here we are seeing payment done using credit card. If you change this one, if you change the class it is referring to, so this class pay method will get called. See, processing payment. So here payment is a reference variable, okay, and where it is referring to this class object. This class object, it is referring to object, okay. New means object. Object of which class? Payment class. So when we call pay, Java checks the actual object at runtime and executes the method, okay. And this all are happening during runtime. That's why we call it as runtime polymorphism. Okay, I hope you understood. Now let's move and let's see the difference between compile time polymorphism and runtime polymorphism. So here they have written method overloading. So we are achieving compile time polymorphism using method overloading. Okay, so method overloading. How method binding is happening means linking method call to method definition. So method call, in method call we will see, we'll check the number of parameters, the data type. So based on the number of parameters and the data type, we will check, we will do the method binding, link the method call to the method definition. If it is having 2 parameters, then we will check for the method definition with 2 parameters. So on this basis, method binding is happening. Whereas in runtime polymorphism, we are achieving by method overriding. Okay, method overriding means child class is overriding parent class method. Okay, now how the method binding will happen? So method binding means linking method call to method definition. So how it will link? It will link on the basis of it is referring to what type of object, which class object it is referring to. So that class method will get called. So that's how method binding takes place in method over this runtime polymorphism. On what type of object it is referring to. This is important statement, okay. So on this basis, so we should be able to understand how to achieve compile time polymorphism using method overloading. How method binding is happening by looking at number of parameters data type. Here we are achieving by method overriding. On what basis method binding is happening? So the reference variable is referring to which class object. So that particular class method will get called. Okay. Now decision at compile time. That's why compile time polymorphism. Decision at runtime. That's why runtime polymorphism. Decision means method binding, linking method call to method definition is happening at compile time. Same at runtime. We call it as a static binding. It is happening at before runtime. That's why static binding. Binding means method binding. Here dynamic, during runtime it is happening. During runtime, what type of object is calling the method? So that class object, that class method will get called. Okay. So since it is happening during compile time, it will be faster. Since it is happening during runtime, it will be slightly slower. And it will be done, method overloading will be done in the same class or subclass. That's why it is same class. Whereas to achieve runtime polymorphism, the concept of parent and child class is used. Okay. So child class will override the existing method of the parent class and give its own version. And on what basis, on what type of object we created, and we are calling that method. So that class will call the method. So on what type of object the reference variable is referring to, so that class object method will get called. I know it might be confusing, but if you see an example and try to understand, it will be very easy. Okay, if you practice once or twice, you will get it. Now, runtime polymorphism makes application more flexible. Why? Because new implementations can be added without changing existing code. Why I am saying without changing existing code? Because parent class will have some method, okay? Parent class will have some method. But we are not modifying any existing method. Instead, we are modifying inside child class and we are overriding the same method. Overriding. So we are not touching the existing method. So that's what flexibility. Okay. And it promotes code reusability. It reduces redundancy. Okay. And loose coupling. So it is reducing dependency between classes. How? Through loose coupling. So we are having same method name but different implementation on both the class. So on what type of object, what type of object we are creating, whether it is from parent class, whether it is from child class. So basis of that, this method will get called. There is no rigidity. That's why it is loose coupling. And it makes application easier to maintain and extend. Okay, it is easier to maintain. And even if we want to extend, we can extend it to further child classes and we can override those methods. So it is easy to extend and maintain. Okay. Now, let's quickly summarize what we have learned so far. So runtime polymorphism is achieved using method overriding. It requires inheritance and it uses a parent class reference that points to a child class object. So on what type of object? What type of object reference variable is referring to? Let's say student s equals to new student. So s is a what? Reference variable, and this is what? Object. So reference variable is referring to student class object. So what type of object reference variable is referring to? So reference variable is referring to student class object. Why object? New. So student class object. So student class method will get called. So that's how method binding happens during runtime. Parent reference. Okay, I explained this one. Method selected during runtime. Okay, so this thing, whatever I explained just now, this will be happening during runtime. And also called dynamic method dispatch. So since we are having the same method name but different implementation in the parent and child class, but during runtime, that is dynamic, the method is getting called. Method binding is happening during runtime. That's why it is called dynamic method dispatch. So that's all for this video. I hope this tutorial helped you to understand the concept of runtime polymorphism in Java. Thanks for watching, and I will see you in the next video.